So this is 3.8, factoring special polynomials. We have dealt with factoring, easy trinomials, factoring by decomposition. Now we're going to go on and learn about 3 special things that we're going to deal with. Factoring a perfect square trinomial is really interesting in that you are not checking for a lot. You are checking if, is this a perfect square, and is this a perfect square? If they are perfect squares, it is a perfect square trinomial. Then all you have to do is take the square root of both of these. You get 2x plus 3, and it's plus because this guy is a plus, and there's 2 of them. And you can even check that. Like if we FOIL this out, we can see that this gives us 4x squared plus 6x plus 6x plus 9, which gives us 4x squared plus 12x plus 9. Yeah. Okay. We are going to rewrite B because it is not in the right order. Okay. Check if they're both perfect squares, and they are. There's a negative sign in the middle, so therefore our term will be negative. So then 5x minus 2 squared. Super easy. All you're checking, first step, is my A value a perfect square and is my C value a perfect square, and you go from there. If we are factoring trinomials that have 2 variables, we must do factoring by decomposition. So first things first, we have an A value associated with our first squared, so then our product must be 2 things that multiply to 6, and our sum must be 2 things that add to -7. We're looking at -6 and -1. So then 2a squared, this breaks down into minus 6ab minus ab plus 3b squared. Chart. Greatest common factor here is a 2 and an a, and that leaves us with an a minus 3b. So remember, we need to make sure that these guys are the same. Looks like just a negative b because we also want this guy to be positive, right? These two we want to be positive. So then when we factor out a negative b, we get a minus 3b. Perfect. So then we're looking at 2a minus b, bracket, 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 a minus 3b, bracket. Same thing over here. We're looking for a product. 2 things that multiply to, oh, I think I'm missing a value here. Yeah, this should have been, there should be a 2 there. So we're looking for 2 things that multiply to -20 and 2 things that add to -1. This is a really popular one. This one will come up a lot. So you will probably end up committing this one to memory, -5 and 4. So then let's break this down. 10 c squared minus 5 cd plus 4 cd d minus 2d squared. Chart. We are going to factor out a 5c. That leaves us with 2c minus d. Then we're going to factor out a 2d, and that leaves us with 2c minus d. Perfect. So that leaves us 5c plus 2d bracket, 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 2c minus d close bracket. Okay, and then our last one, this will probably end up being your favorite one. It's factoring a difference of squares. So the only thing, we don't have a b value anymore. We just have our a and our c. All we're checking is if they're perfect squares. Perfect square, separated by a minus sign. The square root of 25 is 5, and then we add 6x. But unlike perfect square trinomials, it's not the same thing twice. We need to have a negative. And that's because we know that the square root of 36 really is plus or minus 6, because you can go 6 times 6 or -6 times -6. and that both equals 36. If you have a term here that is not a perfect square, first thing that you should check is if you divide by 5, if that will change it. And I'm not allowed, it's not dividing by 5, it's factoring by 5, because we need to keep that 5 around. And that's an important distinction to make. So this leaves us with x4 minus 16 y to the 4. Now, variables that are to the 4 break down into perfect squares. So if it's to the power 4, it is a perfect square. So this leaves us with 5x squared minus 4y squared bracket bracket x squared plus 4y squared bracket. This, you need to stop and check. We know that this is not a difference of squares. There's nothing else left to factor, but there is something here. So we factor it down again. X plus 2y bracket x minus 2y bracket bracket x squared plus 4y squared. Okay. So factoring a difference of squares, make sure that you check that they're perfect squares. If they're not, check to see if you can factor something out to create perfect squares. If it's a variable to the power of 4, that's a perfect square. And keep going until you can't factor anymore.